Hello, everyone. Welcome to DIGA694. This is our Capstone project presentation night, and we're excited that we have three wonderful presentations for everyone. And we're doing this in a really unique manner, and that we have some of our DIGA master's degree candidates in person here on our lovely Winona campus. We also have some folks in class joining us from afar virtually. So even though this is typically an online offering, it's great to be able to see people coming on campus and coming in from all over the place. It's great to see you all here, and of course online as well. And so the purpose of our event here tonight is not only to celebrate capstone experiences. We have a number of them that we'll share, three of them actually, but it's also for the candidates to receive feedback on a really preliminary work. You know, we're kind of towards the end of the capstone, but this is I'll call it a more of a draft final-ish type of product that they're going to share with you. So the idea is we're going to present the findings and then talk about any little last minute things that somebody could consider. So everyone has done valid work in terms of their literature and of course defining their data and their methodology. So we're hoping that a lot of that is pretty well ironed out, but if there's little sidebar things, that's the type of information that we're hoping to share with our candidates here this evening. And so with that being said, wanted to welcome everybody. Folks can come and go. We ask that anyone who does join in that they can have their cameras on, but please mute yourself in that process so that we're not distracting our presenters. But nevertheless, here's a list of our presenters and topics. We'll save Erik and Samir's introduction here in just a moment. But first on our list for our presenters and topics will be our first presenter will be Jesse Lott. Jesse. Hey Heather, how are you doing?
Good.
Thank you for joining in. And we're just getting going with some introductions here, Heather. And so our first presenter will be Jesse Lott. Jesse's joining us from afar, from virtual here. And the rest of us are in Winona on campus here in the frigid Winona, Minnesota. But Jesse's topic is on semiconductor defect image classification with convolutional neural networks. And this idea is something that's really interesting to me personally. One, I love semiconductors. I'm not as deep into it as Jesse is. But the fact that we're able to use really deep learning models and push into the ever-growing expansions of AI, really where that's moving into deep learning is really being a subset of AI and vice versa, and some of the cross-pollination between those two topics. But this is a great application of using a kind of a geo applications, but really for a semiconductor industry, where such as semiconductors that run everything that we have from cell phones to our computers, to our projectors, TVs, everything, anything electronic, really. So Jesse's fortunate enough to bring some SME subject matter expertise into his research, but also is going to show us some ways that he's able to use deep learning and neural networks to help look at manufacturing processes. So with that, Jesse, I will stop sharing and then let you pull up your screen there for us.
All right. Yeah. Let me get going here. And then present mode. All right.
All right. So Jesse, I'm going to leave on our audio here, but if you have any feedback that you're hearing on your end that's distracting, well, maybe I'll just turn our audio off. Okay. And then if I need to,
okay, sure. That's fine.
All right, so Jesse, we'll turn it over to you for the next 20 minutes or so.
Yeah, so this was my capstone project. It's a semiconductor defect image classification with convolutional neural networks. In summary, my name's Jesse Lott. I'm the semiconductor subject matter expert in this. I've spent 21 years in the semiconductor field on a wide range of processes and equipment, ranging from diffusion furnaces, and a lot of my time spent in the chemical mechanical planarization department as a development engineer. where I had developed a 90 nanometer copper CMP process. It was kind of my shining moment. Um, so during that time, defects are kind of the biggest concern that a process engineer comes across. And in our business, my current business, we kind of don't classify these defects as nearly as much as we probably should. And that's mainly because we have older equipment and software that we deal with, and it costs a lot of money to develop these things out and buy new equipment. And so this presented a unique opportunity within our organization to utilize a deep learning method known as the convolutional neural network to do the image classification instead of using a rule-based algorithm for classification. So the overall project I developed was to develop and train a neural network like this and to use it on inline inspection data to make a prediction on defect images that were collected throughout the manufacturing line in a specific module and then report these results. And then why is this helpful? This could be beneficial to a process engineering module owner that wants to just know what his baseline defects are. And it could also be a useful tool for the management of these engineers to kind of steer resources to the top issues. And it can bring attention to, big issues in the factory that need to be shut down quickly. So I hope to make you both a semiconductor and a deep learning experts by the end of this presentation. So we'll see how it goes. So let's start off first. What's a semiconductor? So we got Joe Biden here holding a what's known as a wafer. So this is a silicon disk that an integrated circuit is built on top of. And so as you can see kind of these squares, these are what's known as die. And so this is where the circuit design is etched into the silicon and the chip is really built. And this requires a lot of extensive and expensive tooling and rare earth metals and specialty consumables, and all this stuff drives up costs. And so to make up for these costs, a lot of the times you have volume manufacturing that's needed to make up for these things. And defects are a serious problem to yield as they directly affect revenue. So the better handle you have on your defectivity in a factory, the better yields you get, the better revenues you have in the end. And so, what are the defects we're kind of looking at here? So here's kind of a smorgasbord of defects that are in this particular module. So we have these metal flakes in the top left. These are actually parts of a chamber flaking off during the process and landing on the device and blocking the mask, and then it gets etched and leaves this hole here. Corrosion's another big contributor, and so this is when metals are exposed to chemicals for too long. Incoming's a very large contributor because it can be a whole bunch of different classes, but they're done previous layers. Embedded particles are kind of are a problem as well. Photo related issues can be these void defects. Scratches are a big problem as well. You want to get a handle on those as soon as you see them. Uh, Particles on the surface can show up as kind of these black blotches. And then rough metal is kind of a nuisance defect, but depending on the severity of it can be a problem. So this is kind of like a wide variety of defects that I had in my training and in my data set that I was trying to classify. And so this is kind of a background of where what the defect inspection points are. So what are these defects? Well, they're a particle or unwanted feature on the wafer during the manufacturing. They're very small. They can be the size of a few nanometers or even a few microns if they're really bad. We monitor these through inspection points after each major node, and but then the critical thing to look at right now is that we only classify these when they fail at one of these inspection points. Um, so what's the advantage of using a collusional neural network? Well, you can use PyTorch as the framework, and this is an open source Python library, so it's free. That's kind of the big thing there. Um, and then collusional networks learn from patterns and data rather than a rule, an algorithm that's looking at two different images and saying, are these close enough to each other, right? Um, these can find, as they break up the image into deeper and deeper images, you can find more and more subjected patterns within the data as you go deeper into deeper layers. So there's definitely some advantages to it, and we'll go into some of that. So this purpose of the whole thing is to provide an opportunity to have an AI-driven solution on unharvested data to bring value to the overall organization. Uh, we're going to develop a tool that uses convolutional networks for engineering teams to classify defects that are imaged, classified outside of failing conditions. And then we'll generate a report at the end of these classified predictions. So how does the convolutional neural network look? So we'll take a quick look at this explainer tool that I have found during research. So you have an image that's this input module. So we have three channels in typically. You can have one if you're just doing black and white. But what ends up was doing is we're going across pixel by pixel in each channel, and we're developing a new image out of this. And each one of these sections is known as a neuron. And we take a bunch of inputs into um, a data frame or a tensor, and we connect out the main connecting points of the previous image to give us just the one output on the output image. And then we repeat this so many times to where it just becomes more and more convoluted and deeper until we get to the final area where we flatten out all of our pixels into probabilities, and those are then translated into a logarithmic number and added up. And then depending on that, that's um, our probability of prediction, let's say. Now, I know this is kind of a lot to kind of absorb with not really knowing a whole lot of a background, but there's kind of some key things to take out of this. So we do this by converting the images into tensors. And so you can think of these as arrays of arrays or matrices of matrices. And these allow you to do a lot of this linear algebra work that's going on in the background. A neuron is another key function of this. This allows you to take in multiple inputs and do a single output. So if you have a whole bunch that are red, it shoots out just the blue, right? And then you have layers that are a collection of neurons that tie everything together. Uh, so kernel and weights and biases, these are all other key hyperparameters that help define some of these concepts. So input size, we'll say it's 3. padding allows you to add a buffer area around the actual image, and kernel size actually allows you to change how many pixels you're looking at to give you an output. So we'll go back to the explainer here. And so this is kind of what the model I ended up with. This isn't a very super deep model or anything, but this followed kind of the initial PyTorch documentation, and it got me down the line. And so I used three convolutional layers and did some normalization and connecting layers in between. So we'll see how it goes here in just a few minutes. So how do we analyze this data? So we're effectively looking for model performance. And so literature shows that cross empathy loss is a very good way to measure model performance for multi-classification problems. And so it's defined as log loss. And one key thing with this is you are adding up your probabilities of the specific classes, but then you're also allowing yourself to wait a second. Are you guys able to see the other screen that I have open? I should ask. Or no?
We can see a website.
Okay, good. All right. I'm just making sure. All right. Yeah, so this equation here allows you to um if it's less than the expected value that you would have for, let's say, your car or bell pepper here or espresso, it would drop that particular training module during the training. So this actually it penalizes things that aren't what they should be in during the training methods. And then we have a measure of accuracy, which is the amount of correct versus uh, the total that we have. And so we also have some qualitative measurements based off of our confidence scores and between the different classes, and ultimately bar charts that show the top defect classes that we have. And so this was kind of the accuracy that we ended up with on this particular model. So we do what's called epoch. So that's each training cycle. We're right around 60 to 63% towards the end after 30 training cycles. So not too bad. And then the loss function shows that it drops off and gets almost on nearly on top of the validation set. So this is also showing that the model is doing a pretty good job after the first couple of initiations of training. So there's a confusion matrix between the different classes. So if it were a perfect model, all the bridging defects would only be bridging, all the corrosion would be corrosion, and so forth. Um, so some defect classes had more problems than others. So corrosion was one, and then rough metal was a pretty good one that worked out in the training sections. So overall, this is what the result was from running these on a 8,000 image data set. It showed that bridging and incoming and voids were the top defect concerns during the 5-week period of images collected, which is fairly normal. If you think about where these images came from, they came from a metal etch, a module, and bridging is usually the main concern and the main defect that's going to be there. And then incoming, since it's at the back end of line, you'll be mainly seeing things from underneath. Although voids were kind of a concerning issue, and if I were a process engineer, I would take this the void bucket and try to figure out what's going on with the photo tools and shut those down and look at them. So there's some very good information that you can get out of this with even just the training level that it's currently at. So the confidence levels kind of range for various defect classes. Overall, we're above 50% on most of these, which isn't too bad. Um, some of these more difficult classes, such as incoming, embedded, and even rough metal, have very large tails on each side, and that's mainly because you have some difficult things with some of these images where you have multiple defects seen in the same image. So in this case, embedded is the correct defect classification, but it's picking up corrosion and bridging as well. And really, it's kind of rough metal if you think about it, if you look at it. Another issue was wrong classes altogether. So this kind of goes back to the model not kind of being deep enough and maybe possibly training images not being um, accurate enough to the particular defect class that we're trying to look at. So this one it predicted all these were embedded, but in reality, they're all just rough metal. So I think in general, it works. We produced a trainable model with a very limited data set, and we were able to have some certainty, some reasonable accuracy for a prototype application. It was able to make predictions on almost 8,000 images and reports the results. There's some issues with misclassification, so like we saw with rough metal and corrosion. So I think some additional training images and deeper convolutional layers could help out with some of this. The model itself is somewhat shallow compared to models that were made in 2012 and then even more current ones 2022. So we could be missing a lot of these deeper features in these later layers as well. And kind of the big issue is that this is a very memory intensive ish project. So a GPU is almost a requirement in most cases. Currently, I'm running this on a 4080 Super, which is a mid to high range GPU I bought specifically for this project, and it's already capping it out in some cases. So it's unlikely that a computer in the factory will have this level of a GPU to run this type of training. So, in conclusion, I believe we've made a useful tool for engineering and management to use. We can train this further for better accuracy and better specific defect detection. We can update it with additional deep learning techniques, such as ensemble learning, to kind of bring in other models and get the best prediction out of them. I think it offers a way to know what the baseline defects are that are present outside of failing conditions, since you can run this on almost at any time. We could use this for factory management to steer resources to the top defect issues and other reporting. But the challenge is going to be getting it put online with the GPU requirement. So some future research plans I had for the project was to kind of tie all this up into a GUI interface, graphical user interface with either a web interface using Flask or a desktop interface using TK-Inter to kind of make things commandable and iterable or callable, I should say. I'd like to kind of utilize other models such as a residual net or Google net, shuffle net. There's probably about 15 modernized models out there that you could pick from. I'd also like to try to expand this to other fab modules instead of just metal etch, and then working on reducing the overall CPU or overall memory load, so it can run on a CPU-based system rather than relying on a GPU. And there's also this kind of opened up my eyes to a lot of other areas where convolutional networks and machine vision can be used. there's I want to I don't know. I feel like I kind of want to use this on all kinds of different things and see what the results are. It's kind of an exciting little project that kind of opened my eyes quite a bit. So hopefully I didn't run through that too fast and didn't lose anybody. But other than that, you can let me know if there's any questions or feedback.
All right, so we have a couple people on, first off, thank you, Jesse, but we have a couple people online. And of course, we have our group here, but any questions from our audience initially here on campus? So it could be questions about the semiconductor industry. It could be about Jesse's particular project. Could be anything in between. So I have a couple for you, Jesse, but we'll see.
Sure, go ahead.
So to get ourselves started on this, what would you say was the most frustrating part about Capstone? And then how did you overcome it? Because that's something that we're going to see with a lot of people that, there's struggles in any type of research, Capstone, whatever it is. And we have to find a way through that. And there's oftentimes not a clear defined path. So can you highlight a little bit and share those experiences and what that meant for you and how did you get through that?
Yeah, I mean, I had a pretty big struggle initially, right? So I started doing research on probably three different topics initially back in the beginning of 2024. And I felt like I kind of got into the research funnel loop where it was, I'm not totally certain I want to do this thing or that thing. And what really kind of just drove it home was finding something I was interested in and just sticking to it, right? Sticking to it and then just learning everything you can about it. And like, I'm not a data scientist level, like, engineer, right? So I'm focused on one thing, but like the fact that I could see a problem and then had a tool that I wanted to use and then bring them together and then just kind of, work through the challenges every single day and not giving up, right? That's kind of the key thing is just don't give up, even if it may look like it's kind of grim, just keep going, keep trying. If you got to take a break, go take a break, come back to it. But yeah, just look for the literature, look for the research that's already out there. You know, if something's already kind of been done, well, use that as an example of how to try to move yourself forward, right? And so I think the big challenge with this particular project was there's lots of examples out there for using CNNs, but like they're all very use case and prettied up for the very specific data set that they're working on. So ImageNet is kind of one of those big ones that they try to use everything towards, and there's not a lot of information out there on how to like use the tools that are required to make your own thing work inside of somebody else's stuff, if that makes sense. So, and I think that was kind of one of the big challenges for me in this particular project. But I think in general, it's just not getting hung up and uncertain things and trying to make progress and taking pieces of it at a time. That was another key thing that helped me. Because if I were to look back at this, at the whole entire, project and try to buy it all off at once, I would have gotten burnout easily. But the fact that it was like, okay, every day, okay, I'm going to do this section of it. I'm going to do this research, or I'm going to try to build this part of the proposal, or I'm going to dig into this, literature, or I'm going to look through this website, or keeping it small and keeping it obtainable, I think is another key thing.
Sometimes you don't know that till you start to get through that, but
Oh yeah.
it's for sure there. And so I want to just be mindful of our times on our for our presenters, but were there any other brief questions? If folks in the audience have any questions here live, we can write those down or email those into me, and Jesse, I could share those. But anyone online that is live that may have a question or a comment, or any folks live here tonight?
Not necessarily a question, but more of a comment. Very impressive, Jesse, on the software,
Thanks.
the interface, and how easily that translates to non-professionals in the field. It's a very good presentation.
Thank you.
Yeah, I thought it was really good too. I might have missed this, but how do they find defects currently? Like if they don't use this?
Well, so we do inspections at these critical data points, but we don't classify them. So they'll just show up on a control chart saying number of defects is 25 or 55, right? But you don't know what they are until you go in and drive to them with they do what's called a defect review, and they'll load them onto what's called a scanning electron microscope, and that's what you'll get, these really, really detailed images that are, they can tell you the composition of the defect. It can tell you if it's made out of silicon, oxygen, all that stuff, and then you can get really deep into the definition of it. But you only do that when it fails. And so you can get a lot of information out of these things just by looking at the image without beaming it, right? And there's software out there these days that does this, and it's called auto defect classification, or ADC. But depending on the tool set that you are running it on, it can be a very expensive investment. Like you're talking, and you have to license the software to do it. So the fact that this is free makes a huge opportunity to just kind of do it on your own without having to pay $500,000, $1 million a year to try to have somebody else do it for you. So,
Oh, good job.
thanks.
Thank you, Heather, for the great question. And so with that, for the rest of the folks here, if you have any comments, questions, write them to me, and I'll make sure Jesse gets them as we transition over to our next presenter here this evening. And so with that, I'd just like to pull up and to make sure folks can see this here at home. So our next presenter has something that is typically not often seen when we think of the world of geo and data intelligence. This is a portrayal of a story that has meaning, with that of geonarratives. And in other words, how can we extract data and create a narrative around an experience? And so Erik will be coming up front here in just a moment. And this is a really novel approach to taking a look at a World War II journal. And I'll let Erik share a little bit more details on that, and portraying and extracting meaning out of that to share in a geo-visualization, but also the importance of richness and interpretation and meaning of experiences at the time when this journal was crafted. And so with that, I'll invite Erik Madland up, and he will share some of his work regarding developing geonarratives through geographic information systems, qualitative narrative analysis, kind of a long one for me here, and multimedia integration and evaluation of a sailor's World War II journal. So with that, Erik, let me just get this up here. Get this ribbon here. Okay. Oops. All right. Just going to stop the share here just for a moment. Okay, Erik, so we will get you up and running here and turn it over to you. So Erik, welcome. Thank you.
Excellent. And thank you, Dr. John, for the introduction and brief description of the presentation on hand. So developing geonarratives from a qualitative narration does enhance and enrich the topic at hand. So it involves in creating this qualitative narrative, which is, especially compared to Jesse's and Samir's and a lot of the presentations, as Dr. John was mentioning, it's a more conceptual idea of an approach on implementing GIS to enhance those qualitative narratives. So what is a geonarrative? Dr. Kwan describes a geonarrative as extending, well, as you can see here, this window wasn't in the way. So we go ahead in the capabilities and the analysis. So we interpret the narrative in the materials beyond what is written by incorporating the situation, the environment, maybe that person's own history and his perception of how things may be, incorporate supporting materials that were referenced in the narration, as well as documents, imagery, and other supporting information. So this broadens what would be just a simple text into visual and analytical potential. And so that being the purpose, to create a geonarrative that would enhance and enrich the qualitative value of a narration through spatial and visual analysis and representation, resulting in a more comprehensive evaluation of the qualitative narrative, which is the goal. I want to expand the value of the qualitative narrative. And we're going to use GIS to do that. So I'll give a little background. One of the things lacking is in the whole geonarrative approach is the lack of standardization and implementation of in any kind of processes that might have proven successful. There are a lot of visualizations from narrations that exist now, and you would see them in multiple areas as far as just representing quick requests on a visual from some kind of documentation. However, so the idea is not new. What is lacking is the structure behind it and some organization. There's currently no software developed that really translates this information from a narration into a GIS environment. So with this background, I've broken it up into 5 components, and this is just a concept that I've noticed in the patterns of establishing these geonarratives and trying to get stories out into a visual realm. So, and that includes the narrative analysis, the qualitative and quantitative aspects, of course, the visualization that can be incorporated, and then all the supporting material, such as media, documentation, imagery. So in the background here, I'm going to go briefly describe those 5 components, and in a fashion that can be used by the audience for mostly any narrative. The idea being a loose template in conceptual form. So the narrative analysis, that's the first thing we did do is confirm the viability of that. See how compatible it might be with GIS. Time location stuff usually works well, such as the noted historical accounts or biographies, journals, and other studies that follow kind of a date, time, and event or of sorts. So next, the qualitative aspects. So if it's deemed narrative, it would be a good candidate for a qualitative analysis into GIS. We would then compile that data, identify the patterns, incorporate that into GIS, and then we would start highlighting and interpreting the content within the narrative. With this, we want to bring out those topics that maybe not so easily identifiable through just reading a text page 1 to end. Quantitative. So some of this stuff, some of the content in the narrations are more subjective, and sometimes we like to create analysis out of that. And to do that, we can create a rating system, well-defined parameters to go ahead and establish the conversion of what might be subjective into a more quantitative rating system based on the content. So that would involve, it would be very customized to what your narration is trying to accomplish. However, when we have subjective data that we want to quantify for analysis and spatial reasons and visual representations, this is where that works out well. Otherwise, just common benefits of GIS incorporation, such as visualization, symbolizing themes and whatnot, the whole spatial representation that you see. And, a lot of people are visual, so that kind of ties it quickly, but they also seem to remember it a long ways after. I know I do. So timelines, we can also incorporate this data into other visualizations such as graphs, charts, and any type of visual representation that we have the data for, typically attributes and how they're represented. Finally, we can incorporate multimedia and supporting material through GIS for the narrative. So this might include, the actual images of the qualitative narration, which might be a handwritten book that has not been digitalized. And then we can go ahead and add videos, related documents, and basically any kind of media you can imagine that would benefit the story can be incorporated. And so to access this is typically attachments or links. Again, that's right through GIS. You can go to those online sources and find that supportive information. And through our methods and results, we'll go over this background and these 5 components and how they worked out in the methods and results. So the background summary then being the just a guideline of information of conceptual components that might be necessary for the development of that.
Yeah, feel free to actually drag that window a little bit around there.
Right. So again, as we just summarized in the background, you got the narrative analysis, analyze the content, qualitative into GIS. Okay, we're going to plot those GIS. Quantitative. Excuse the lack of. Oops. So we go ahead, qualitative, the quantitative, and then we do the visual representation and the media. In the end, we should develop a geonarrative. It doesn't have to be a linear approach. However, some of it does work better that way. Obviously, starting off with the narrative analysis to see if you should even proceed. And so we'll go ahead and go over some of those methods and results of those 5 components. The World War II journal is going to be the example used for this. And so this is a journal, written by a sailor, Robert Beard. He was a diesel mechanic for his company. And this was his story. And now a lot of the journal, you can only write so many things in there for, if you were to get captured or if the journal was to be found by the enemy. Can't get into too many details, but it is very interesting. A piece of narration to experiment on. So the methods described will be the result of these geonarrative analysis. Again, just want to go over the same thing, but here we are getting it into there. So first, we're going to do the narrative analysis, evaluating the content as we described in the background. Confirm that we can develop a geonarrative, check out some themes, document those themes, highlight them as we're going through that narration. And then also, focus on some maybe impactful quotations and other things that pop out and would grab the audience's attention. And here's just kind of a more of a detailed workflow on how you might approach that. The results being more or less digitalizing it as you needed to, confirming that information was there, converting, and representing it. So from here, we can go ahead and see that this conversion would then be typed into documentation for easy reading, obviously, and as well as audio and maybe more enhanced access to this information. So at this point, we can go ahead and assume that we can develop a geonarrative. So we're going to go ahead and put that qualitative data into GIS, creating point features, relative, it might be lines, polys, depends on what you're doing. Again, the journal here, point features, assign the attributes, and make sure we take the imagery of those original documents and the text versions, not just as a whole, but we're going to need to break them down into segments that will be linked to each point. So basically, each entry will need an image file and a text file for the entry relating just to that point. So a little work breaking it down. Go ahead and plot those into GIS, populate the attributes. So there we have the qualitative analysis, the results. Here on the far left here, we have extracts of this entry, number 22. I'm not going to go over them all, but this is how we can start deriving subjective data and start analyzing themes and patterns by breaking down the content into categories and really understanding what is going on behind it. This one is of an invasion in Sicily. Sorry, hitting those as if they were going to connect. So we have an example here of the attributes. you have your locations, the basic information. But then we have domain associated features such as the stage of war, this being the invasion of Sicily, the highlights that were found in this single entry. And then, of course, we have links to the, again, the imagery and the text entry. The morale rating given through the quantitative analysis was a 1, and we'll get into detail shortly. And then we were able to provide media links for information that was referenced in that entry. So let's do some quantitative analysis now that we have some subjective data to deal with, and we want to try to get more of a grasp and again understand the qualitative aspect of this narration. So we're going to gauge the morale throughout the war would be the example given here. And then, so to do that, we're going to just formulate a rating system. For this one, I went into 3 tiers. The first one being, invasions and raids and subs and mines. That's a high level factors that would greatly impact morale. Next, we have a liberty, meaning time off, go tour the towns or whatever, the work tasks at hand, and then anything going on with the ship, being a diesel mechanic for that ship. And then you go into the lesser tiered ones of, foods, friends, and sleeping quarters. It's all important for morale, but it was tiered up a little for those reasons, resulting in creating a spreadsheet that compiles this data, broken down into these 3 subjects, each given a different tier. So as you see, so what we have here are a tally of the points assigned per entry. So if we have an entry on the side here, it's going to correlate with any information that was given in that entry relating to any of those 9 topics. And at that point, depending on what that content is, that would be rated accordingly to the morale ratings. Typically 2 through 4. I did decide to give peacetime a 5. And then we have imminent danger where it is just that. So through those 5 ratings, try to establish the total morale by taking the total of the tiered points and bringing it to the total morale rating. And another caveat is adding 1 point for being in the United States. Just the morale of being on homeland was given an extra point. And again, these are all arbitrary, customary, rationalized, I shouldn't say arbitrary, but very unique to the narrative at hand. Next, we kind of just go into the visualizations and spatial representations, typically what GIS is known for. So we can go ahead and utilize the information that we've compiled in the narratives, that we've brought over to the attributes, and what we have been able to analyze through the quantitative and qualitative information that was given. And then the real simple spatial representations, visuals, some examples would be the dates, stages of war, whether it's training or prepping for an invasion or during an invasion or homebound or whatnot. And the entry types, if it's non-combat, if we're more or less traveling from country to country, it's that would be relative. So domains are established for some of those. And again, those are really quick, easy, very fundamental visuals to compile. And we can also use often the chronological order of events exists to where we can start making graphs and charts with timeline orientation and then the other attribute information associated with that. And again, on the right, we have more of a detailed, almost how-to of what you would do to get that accomplished, resulting in, again, these are as basic as you get, but we have one for dates with labels of exact dates, dated by year. The symbology is given by year and with labels of the exact dates. The morale map was the compilation of the subjective quantitative data that was given these morale ratings. And as you can see, it pretty well corresponds with what you might expect. An invasion in Sicily, D-Day invasion in France, being the imminent danger, while we have the peacetime out here. And it was in Pearl Harbor where he was at when it was declared peace. So he didn't actually have to go too far into the Pacific. And then the results. Sorry. And so the next final method he presented here as concept is the multimedia integration supporting material. So we, again, can enhance qualitative value through further explaining these historical events that are referenced in the documentation, concurrent events at the time of the entry, and just more personal accounts, whether it be from those around him, others experiencing the same situation. Of course, attribute fields everywhere for linking this. And then an example given would be entry 22, an invasion of Sicily, and linking that information, we see these two references in the journal. So this would be an example of a reference where things were not looking so good. All hell is breaking loose. So this is a very emotional and impactful quotation extracted that is not just in itself a very substantive to the reader, but we can also go further and hit these links, which will bring you to some of that supporting information. This one brought by the Navy. And we have here is a link, just the links in there. The second link provided was the reference to the sinking of the LST. So my grandpa was eating chow with the rest of them. And a second after they miss us, they hit 158. She was in a mass of flames. We could hear the ammunition blow up. They hit her square midship. There were very few survivors from such a direct hit. So he witnessed this live right after his ship was 30 feet off from having the same outcome. And so with that, you go ahead and do those sources there. Oop. Yeah, let's see. Where to go? All right. All right. So I knew we'd experience that by hitting the link, but here are some images then, and again, just further supporting information. So, in conclusion, some of the discussion would be, they can be developed through the concepts of the 5 components provided. By utilizing those, hopefully you can develop a geonarrative, considerations on the meaning derived from the raw data. This can be subjective and interpretive, and the supporting material incorporated that can back up some of that interpretation. General findings is, just looking for that fundamental data to create that geonarrative, collecting that data and creating that interactive map where it makes sense and to visualize that information in that spatial format. Some limitations would be, again, the lack of standardized methods and supporting software available. Now, there's always bias to prioritizations and assigning, especially when we try to create quantitative from subjective data. But those are challenges that can all be defined in parameters. Different perspectives. Again, we have a little quotation, regarding the need for more research into this workflow, this standardization of bringing qualitative narratives into the spatial realm of GIS. So I don't know, any further recommendations for this particular one would be create additional features, further enhance that narrative, improve the data being interpreted, additional research versus that supporting information to be provided, and again, apply this concept to any qualitative narrative. Conclusion being that we can achieve this through the concepts given here in orange. By utilizing those through these steps, the steps, the rationalization seen in the background, the implementation method given in the method section, and the resulting information may just bring up the value of that qualitative narration. Yes, and that's about it. Trying to bring kind of a real broad general concept into something more tangible and process based.
Okay, so we'll take, I'm just looking at the timer. Eric, if you want to head over to the screen now, we do have a couple of questions, and I can moderate that for anyone who may have a question. Anyone? Well, there was a question from the audience on my way up that just because of timer. The question, if I'm paraphrasing this correctly, was, what did this whole process mean to you? You obviously had a personal connection with it. And what did it mean to you now that you were able to go through, synthesize this information, visualize it, and connect history with your family to see it in a different way? I guess I'm not paraphrasing that correctly, but that was the one of the questions I had on the way up.
Yeah, so the benefit of this project was to really get to know not just my grandfather through this journal. It meant a lot personally in that factor. But I also can see all the benefits where that same aspect can be utilized, the same tool narratives. Recently, family passed away, and I was like, well, a celebration of life ceremony or funeral would, have up a nice map of their life as it goes, and there's just so many possibilities with this. That meant a lot to me to know the history of my grandfather, to know what he went through and to experience what others went through around him, and just a greater appreciation of all he and they did at that time.
Yeah, there's no doubt it's a moving connection from so many different angles. And I'm glad that you're able to do this. This is a wonderful thing there. And so anyone at home with a question or online?
I don't have a question. I just thought that was a very cool idea. Just something I never would have thought about. So that was awesome.
Right on, thank you.
All right. Well, thank you for the comment, Heather. And some of the others, again, we'll take your comments, filter it to Erik in lieu of time. And so Erik, thank you very much. Not only congratulations to Jesse, but to you, Erik, as well. We'll save the applause for later so we can introduce our next speaker. So
Thank you, Dr. John.
yes, you're
Thank you.
welcome. All right. All right. Okay, and our last speaker of the evening here is, we'll bring him up here momentarily. All right, so Samir will be concluding our Capstone event evening, our concluding Capstone speaker here for our event. And Samir is a really interesting project as well that gets a little bit more into the business side as part of our program has options to study in business engineering. And some of it can be geospatial, some of it can be data engineering, some of it can be business engineering, some of it can be AI, some of it can be geonarratives. But Samir is a really wonderful topic that looks at exploring supply chain and supply chain management practices from the leadership and ethical performance perspective, which really shines a really important light on how organizations can effectively monitor and make sense out of this, the perspectives and what's going on in different organizations across the board. So with that, Samir, I will invite you up and welcome you to the stage here. So
thank you, Dr. John. And thank you for the nice introduction. And I think you have covered everything from your good introduction about my topic. I need not to tell anything about my thesis or research on this. By the way, thank you, everyone. Hello, everyone. My name is sounds coming. Oh, sorry.
okay, there we go. All good. Oh,
Sorry for the disruption. This is supply chain disruption. Okay, yeah, just kidding. Okay, yeah, real time, yeah. So the topic of the my capstone is unraveling the impact of sustainable supply chain and management practices on supply chain performance. And my name is Muhammed Uddin, and I'm the international student in the USA, and I'm studying here DIGA with business emphasis or business engineering. Thank you, everyone, and welcome to the presentation. So here is the introduction to the study. So Dr. John already mentioned that this study usually focuses on the sustainable supply chain management practice. And let us know, and let me tell you what is supply chain. Supply chain is a network of organization, people, activities, information, and resources involved in producing, delivering a product or services from suppliers to customers. It includes procurement, manufacturing, distribution, and logistics department. And what is referred by sustainable? So we understand what is disruption. So anything against disruption is sustainable, okay? So if I conclude like this, it focuses on balancing economic, environmental, and social considerations for long-term viability. So this is sustainability. Another two term is from this topic is management practice. It refers to the strategies, methods, and techniques that managers or leaders use to plan, organize, lead, and control resources effectively to achieve organizational goals. Last but not the least, ethical dilemma. the ethical dilemma is a situation where a person must choose between two or more conflicting moral principles or actions, making it difficult to determine the right course of actions. So the goal of the study was to improve the supply chain performance. Of course, the supply chain performance is being evaluated through the financial and operational performance and the leadership and sustainability impact on it. So in the picture, you can depict that how supply chain works in an organization from supplier to the end customers. The objective of the research was examining the impact of sustainable supply chain and sustainable supply chain and management practice on supply chain performance. So this topic will answer or try to find 3 answers from this question. Number 1 is that to what extent do sustainable supply chain and supply chain management practice directly impact supply chain performance? To what extent does ethical dilemma mediate the relationship between sustainable supply chain and supply chain performance? Last but not the least, to what extent does leadership quality mediate the relationship between sustainable supply chain management practice and supply chain performance? So now moving to the conceptual framework. A conceptual framework is a structured outline that visually or narratively explains the relationship among the key variables or concept in the study. It provides a foundation of the research by defining what to study, the concentration connection between variables and the expected outcomes. This paper or research will the effect of the sustainable supply chain management practice, leadership quality, ethical dilemma, and supply chain performance. So these all 5 components are the elements of the conceptual framework. So this is the conceptual framework. We depict here the 5 latent variable. Out of 5, 4 are the independent variable and 1 is the dependent variable. So ethical dilemma, sustainable supply chain management practice, leadership quality, these 4 are the independent variable and supply chain performance is the dependent variable. Now hypothesis development. So we understand that hypothesis is the educated guess, and this is the process, a testable statement or prediction about the relationship between 2 or more variables. It serves as the basis for research and is either supported or rejected through data analysis. So in this research, we have developed a total 12 hypotheses, but for the ease of understanding, we have clustered them into 4 broad categories, and they are: number 1, impact of sustainable supply chain on supply chain performance. This one. Second one, impact of supply chain management practices on ethical dilemma. This one. The role of leadership quality in supply chain performance. This one. And last but not the least, the role of ethical dilemma in supply chain performance. The last one. So these are the cluster of the hypotheses. So we have total 12 hypotheses. We'll be seeing that in the result and discussion part. Now methodology review. So if we look at the methodology, this study took 350 sample. So that means the 350 respondents were under this study, and analysis approach was the PLS-SEM. What is it? It is a partial least square structural equation model. So this is purely statistical technique. And to do this, we use the 5-point Likert scale for the measurement model. That is 1 for the poor and 5 is the high satisfaction level. And software I used for this analysis is the Smart PLS, that is statistical software, SPSS, and Excel. And the right-hand side, you can see the total research process. So at the top, the research, and the research is conducted the descriptive. Descriptive means it analyzes so many things like central tendency, spread, etc. So I will discuss it later. So it is descriptive research, and from here there's a cross-sectional and longitudinal study. Of course, I did not go through the longitudinal study because it involves historical data, but I took the secondary data from the market survey, that is the cross-sectional for a specific point of time. And from the cross-sectional study, I took the questionnaire survey method, and here it is self-completion and the interview administered. And it's, of course, data collection was by self-administered, and the place of data collection was the Bangladesh. Now, data analysis method. So data analysis method, we use the descriptive statistics and structural equation model. So under the structural equation model, we used measurement model and structural model. So if I want to explain the measurement model and structural model, if you see, this is the latent variable, these two is the latent variable, and these are the unobservable variable. So these are the measurement model, and when this latent variable is connected to that latent variable, there is a dependent variable. This is the structure model. Okay. Now move on to the descriptive statistics. So descriptive statistics summarizes and describes the main features of the dataset using measures like mean, median, mode, that is a central tendency, variance, standard deviation, which is the spread, and visualization like charts, graph, etc. They provide a simple overview of the data without making inference. So from the study, we have found that understand that total 350 sample size, and there is no missing value. Normality is okay. There is a normal distribution. There is no skewness. Everything is okay. Kurtosis is okay. All are under the control and within the threshold value. Standard deviation is comparatively low. That is okay for the analysis. Overall data quality meets the normality assumptions for further analysis. So descriptive statistics is a foundation and the first step to go further. If there is any problem like missing value, normality, etc., so we have to check back and look at the data set again. Unless we cannot fix it, we cannot move to the structural equation model. That is the measurement model and structural model. Now the measurement model. The measurement model tells us in the structural equation model defines the relationship between the latent variable, that is the unobservable construct, and their observed indicators, that is a measurable item. It tells the validity and reliability of the data. So when we consider the measurement model of a statistical study, we take care of these items like Cronbach alpha, composite reliability, indicators loading, average variance expected, that is shortly referred as AVE, cross loadings, and Fonderlarker criteria, that is the correlation. So these are the decision criteria. So Cronbach alpha and composite reliability is measure the reliability of the data. Okay. And indicators loading is the latent, these are the indicators of this loading. So all these things are under control. So Cronbach alpha or composite reliability must be 0.65 and above. And if it is a 95%, that is very good data quality. It qualifies the data. How qualitative is the data? It quantify like this. And AV also the validity. If it is above 0.5, that means your data is valid. Okay, that is valid means you have no any collinearity impact. And cross-loadings, for cross-loadings, we can consider data above 0.6 or 0.65 for all the construct. And for the structural model, we look into the collinearity, path coefficient determination, that is the R square, effect size, that is the F square value, predictive relevance or Q square value. So these are the decision criteria for the structure model. So structure model will define through the hypothesis testing or regression analysis. Okay. So from the structure model and measurement model, so this is a complete model. Okay. So this is a complete model. This is the latent variable. This is the latent variable, and this is the unobserved variable. So all together, we composed the structure model for the data analysis. Now discussion and the result. Earlier we have seen that for the measurement model, we have to look at we have to look at the t-value, outer loadings, Cronbach alpha, composite reliability, and average expected variance. So we have seen the threshold value, and here is the actual value. So all the figures are green. That means we have passed the measurement model. And for the measurement model, we have considered all the factors, items here for ethical dilemma. Under ethical dilemma, there is a 4 construct or the variable. So that is the unobserved variable. Okay. For leadership, 4 supply chain management practice, for every individual independent variable, we have to develop 4 construct for each, so that the measurement would be equal weighted, and all the criteria met the expected value. Structure model. So structure model, we have to look at the collinearity, path coefficient, coefficient of determination. So all the criteria met the expected value. There is a criteria and this is the expected result. So all the value are under our threshold value or the above. So this criteria passes the structural model. Hypothesis testing. This is the regression analysis. That is the relationship between the independent variable and dependent variable. So we mentioned that independent variable we have 4. That is a sustainable supply chain management practice, ethical dilemma, and leadership quality. And what is our dependent variable? Dependent variable is the supply chain performance. So this independent variable, whether influence the supply chain performance or not, this will be tested through the hypothesis testing. So we run the model in the smart PLS. So I mentioned that we have a 12 hypotheses. So here's a total 12 hypotheses. So out of 12, 4 are the mediating variable. That is the mediating variable, ethical dilemma, where the ethical dilemma mediate the relationship between the sustainable supply chain and supply chain performance, and whether leadership quality mediate the relationship between the supply chain management practice and supply chain performance. So these 4 are the mediating or indirect effect, and another 8 are the direct effect. So out of total 12 hypotheses, only 3 hypotheses is not supported. That means we have to reject that hypothesis. That means first one is the supply chain sustainability on ethical dilemma. So it rejected. So it is not supported. And another 2 was the supply chain management on ethical dilemma through to supply chain performance. So these hypotheses also rejected. And supply chain, sustainable supply chain, ethical dilemma, and supply chain performance. So these hypotheses also not supported. So this is rejected. Out of these 3, all other 9 hypotheses are accepted. So recommendation. So from the hypothesis and another analysis, the recommendation is coming like here. Importance of sustainable supply chain and supply chain management practice. So sustainable supply chain and supply chain management practice play a crucial role in improving supply chain performance by fostering operational efficiency, cost efficiency, and brand reputations. Leadership quality, significant mediator that enhances supply chain performance by promoting ethical and collaborative culture. Ethical dilemmas. Managing ethical dilemmas can reduce reputational risk and improve supply chain performance by aligning operations with ethical standards. The limitations of this study. I mentioned in the research design that this was the cross-sectional study. We did not consider the historical or the longitudinal data. So this is one of the limitations of the study. And geographical, that is the generalizability. So we considered the data from the selected segment of the country like Bangladesh. So this is one of the limitations. For the greater generalizability, if you consider the other countries, so it would have been much better. And self-reported data, that means the potential response bias, especially concerning ethical dilemma. So when we ask any question to the respondent, so if they answer their own ethical dilemma, so this might bias their own responses. The focus on specific mediator like leadership and ethical dilemma are the only mediator examined. Other factors like organizational culture or technological innovation were not considered in this study. And industry-specific context findings may not be applicable to industries beyond the studied sector. So this is all. If you have any questions, please.
All right, let's see here. Had a couple of questions that came through here for us. Let's see where our window went here. There we go. All right. I'm finding that I've had a list of comments here from folks in our audience, but folks joining us from a far distance, any questions or comments on your end or other presenters that are here this evening?
I think you just did a really great job laying all of that out. That was very succinct.
Yeah, so the first part got a little bit audio cropped out of there. Heather, would you mind be able to repeat what you were just saying there? I don't know.
Yep. I just said it was very succinct and very well laid out. Great visuals.
Thank you.
Mhm.
And so one comment was fielded talking about the potential of bias. You know, and you kind of talked about at the end there. Whenever this is kind of a global thought, you know, for anybody here or at home or wherever you all may be, you know, when you talked a lot about the data validity,
Yeah.
you know, and the statistics, and that helps validate what we have. One thing that we always, for us all, have to be mindful of is what can creep in to maybe, even though our statistics can make our data valid, what is going on with threats to the internal validity? So in some classes, we talk about internal validity, such as data collector bias, not that you or any of us are collecting it, but it could be from the subject, you know, or a population in Samir's case. So what if any, so getting back to, I'm just paraphrasing this question here from the audience. What would be some of the potential biases that you could see in the data? I know you kind of highlighted that depending on their background or whatnot, but what would you see as potential?
The potential bias may come from the respondent when we ask them a specific question with regard to the ethical dilemma or the leadership. So when they will answer, so they have a fear of their understanding that their response might be shared with this management. So on that note, they might not answer properly, okay? Because this issue might be very would affect badly on their performance or the anything like that. So on that context, they sometimes it happens, so they might not answer what they intend to answer with regard to their questions or the organization. So that can also be resolved. That is, we use the validity test with the data. So that is why we consider 0.5 and above. Okay. So there is so many criteria for validity test. If that surpasses that, we can understand, we can take the data as valid. So that is why we run so many statistical tests to see whether the data or the responses are free of bias or not.
So I think you had, just to piggyback on that, when in doubt, we have to look at our sample size. So I think for yours, you had 350?
350, yeah.
350.
I distributed 385 or 89 questionnaires. So from there, I took 350. So other were some missing values or inappropriately filled up. So that's why that was rejected.
Yeah, so kind of when in doubt, we increase our N, or sample size. That helps us to kind of
Exactly,
level
exactly,
those.
exactly. So we took the sample size 350, but when we ran the model in the smart PLS or the SPSS, there is a options. Then you can run with 5,000, 10,000 data sets. So that extrapolate the data to conduct the study. So this is how the validity also tested, being tested. Yeah.
So I personally, knowing a little bit more about your topic, working with you, there are a lot of programmed principles, if you will, of structure threaded in to helping ensure the extrapolation of bias or validity maybe is reduced.
Yeah.
Yes.
So that's term called the bootstrap.
Yes.
Bootstrap. Yeah, we ran
Yes.
the bootstrap. So I run at 5,000 data bootstrapping. Okay, to run the validity. So as long as the data size is bigger, the validity would be higher.
Yes. Yes. One of the other questions here from the audience spoke, and you also kind of highlighted this a little bit towards the end. Here is talking about what do you see as the potential for your model being able to scale this out? Do you see any limitations in being able to scale this? I know if you were talking, you spoke about generalization.
Yeah, generalization. Yeah, exactly.
What do you think this model, if I'm just kind of going to summarize that question there or comment. Do you see any real limitations in taking what you did and serving that up to an
Exactly,
organization?
exactly. That's one of the limitations. Okay, the model work in Bangladesh context, whether it will work in the USA context or not. So that is the limitations. So if I had the chance to collect the data within the short period of time, so this would have been much better to check the validity and reliability of the data, whether this model or concept is actually will fit in this model or not. So that is the issue.
Yes. Okay.
Yeah.
And that's in any
Exactly.
in any study that anybody's doing there.
Yeah.
Another question, kind of a fun one, is how long did it take you to learn some of your statistical programs that you have in there?
Thank you. I forgot to mention that this topic I chosen from the business engineering. So I learned their statistics, operations management, business analytics, and managerial ethics. So ethical dilemma, the variable is coming from the managerial ethics. The measurement model, structure model, descriptive analytics are coming from the statistics, and other analysis coming from the business analytics. So all these concepts are incorporated in these things. But my background is for statistics is far better because I'm graduated, I'm PhD graduated. I completed my PhD from Malaysia. So there I learned how to conduct the research or data analysis using the statistics or the tools, everything. So I have been using this statistic for the last 4 or 5 years.
Thank you. I hope that answers your question there. And so another question that I have here from the audience is, how does your work, your output, tie into that of literature that you have maybe been working with? Do you see it sort of converging or diverging with what you found in the literature?
Yeah, for this study, I had to go through the more than 50 literature review or the journal papers. So all these are coming from the USA, Australia, UK, or India, or Asia scholars or the researchers channel. So they have also tested these sort of things. For example, when we are talking about the reliability or validity, for example, I have taken 4 construct for each independent variable. Okay, so 4 into 5. I have 5 independent variables, then 4 constructs. So how many? 25. That means I have 25 questions. So these 25 questions or variable was not developed by myself. That was not myself. So these were tested by other researcher. So this is how we conduct the one level of the internal reliability. Okay, internally. So those questions are picked from the other researcher. We have already tested those things. So on this basis, I tested this reliability in my country context. So this is how we conduct the study. So of course it converge and diverge. So through the prior the journal or article. So this incorporate all the ideas that we studied earlier and how it could be applied in the new idea. So this is how it works.
Yeah, and you bring up a good point, which is why in not only Capstone, but anything we do in research, whether it's in the industry or in school, we have literature that serves to back up or support our data, and our methods. So an instrument such as this that you use, Samir, has been demonstrated. I mean, we could put your little your sprinkles of your own empirical work into that. However, a lot of that has been vetted for us. So in other words, we don't have to always go out and reinvent the wheel, so to speak, which helps them making your entire design more valid as well.
Yeah.
So one of the last question or comments here was kind of akin to some of our other presenters, both online and here. What did this whole experience mean to you now that you've gone through this? What did it mean to you personally, maybe professionally?
Good question. So the thing I like to do research. So there is a one thing I really want to tell about the thing. When I got the chance for the Capstone project, so this was a really good chance. So how to understand how I understood from the earlier study like the operations management, business analytics, or the data analytics or managerial ethics. So I tried to incorporate all the things from the Capstone project matter. So this is really eye-opening for me, so that I can understand how to capitalize the data or the theory into the practical phase. So this is helpful for me for the future study or the research.
And just to piggyback on what Samir was saying, but also for Jesse and for Erik, the idea with a lot of our papers that are produced is we like to publish those. And so the school, right over here in our library on campus, that is, we'll have a big volume of papers. And it is the hope that with a little refinement in our formatting and whatever else, that we can bundle those up into journals that'll be available, so that your capstones are going to live digitally, or even in the library from a lot of the work. So for Jesse, and let me pull up the window here so we can see everybody here. So for Jesse and Erik and Samir, for all of your work and those folks that preceded you and that are still, kind of coming along here, there's a ton of really great intellectual contributions to this field. And so I wanted, on behalf of our department and faculty and staff and here with the university, to thank you so very much, Jesse, yourself included there online, for all the hard work that you committed to this, because these are some really cool topics. And it was clear to me the amount of energy and hard work you put into this really made it shine. And so keep in mind, for folks that are watching this either after the fact or in the audience here tonight, these are kind of non-polished. They're semi-polished pieces of work, but we still have the final journal papers to go through. So a lot of the details and the greater specificity of procedural things, methodological things, will be present in those journals. So look for those to come. We're building a new volume, so it may be a little bit before that goes to press, but we'll have the journals, at least in digital form, once we sign off and approve those, to congratulate and also graduate you all. So Jesse, Erik, and Samir, congratulations to you all on behalf of us all here. And so I wanted to thank you for that very much. So
Thank you.
you're welcome. So with that, I'm just going to stop the recording, and then we'll do our applause and some closing items there. So thank you, everybody, for your attendance. And again, congratulations once again to you all.